part 2 of our Extension 2 Integration Lesson 1, a couple of harder substitutions that you may come across. For example, integrate 1 over the square root of our quadratic function. Now, when we're looking at these sorts of things, we consult our table of standard integrals, and we see this is kind of almost like 1 over root a squared minus x squared dx, which is, of course, inverse sine of x on a. So what we need to try and do is manipulate that expression underneath the square root sign in such a way that it fits the standard integral table, possibly with a substitution. So looking at that quadratic, 8 plus 8x minus 16x squared, let's just split it up a little bit, and now we're going to complete the square. Completing the square on both those things, and we get 9 minus 4x minus 1 all squared, which of course now fits quite nicely, and hopefully you should be able to see that using a substitution now we can solve this integration problem. The obvious substitution is to let u equal 4x minus 1, therefore du equals 4 dx, and substituting in, we now have a much simpler integral of 1/4 outside the integral of 1 over the square root of 9 minus u squared du, which of course is just a standard integral, and using the standard integral table, or the one we've got in the top right hand corner, we get 1/4 inverse sine of u on 3, and substituting back in now for u, we get our final solution of 1/4 inverse sine of 4x minus 1 on 3, of course plus a constant. So you can see how algebraic manipulation and recognizing and looking for patterns, so anything or any constant over a square root of a quadratic function will be some form of inverse trig. So you've just got to get the experience of looking and seeing what sort of manipulation might make it fit a standard integral. Another example, occasionally you're actually told which substitution to use. There's more than one way of actually doing this particular integral, but you're told in this case you have to use the substitution u squared equals 3 plus x. Well, letting u squared equal 3 plus x and differentiating both sides, we get 2u du equals dx. Therefore, x is u squared minus 3. To make this problem simpler, we'll actually just change our limits as well. When x is 0, u is root 3, and we don't need to consider the positive and negative values here because quite obviously u must be positive because u squared is 3 plus x, and we need to have a positive number underneath that square root sign. And when x is 6, u is 3. So our integral reduces to something much simpler, replacing our x with our u squared minus 3, our root 3 plus x with our root u squared, and our dx with 2u du. Now you can see the reason we made the substitution with a u squared here is because it goes away on the bottom, because the square root of u squared is u, and then we can simplify by cancelling out the u in the denominator with a u in the numerator, and we get quite a simple integral to evaluate. It becomes the integral between root 3 and 3, substituting in our limits we evaluated previously, of 2u squared minus 6 du, which is a very straightforward integral to evaluate, 2/3 u cubed minus 6u between the bounds of root 3 and 3, and if you evaluate that, you get the final solution, which is 4 root 3. So hopefully you can see there's a variety of different ways of actually using substitutions, and occasionally it's better to evaluate the limits, and the whole process is really about trying to do any form of algebraic manipulation to make it fit a standard integral.